scope of what we are talking with AIKM. So the pre-class assignment was sent out to you. It was a chapter in a book for knowledge management from a technology perspective from Vincent, and that was the pre-class reading. So we'll have a question on that, and we'll actually revisit that question during the end of the presentation or session when we talk about, will computers actually emulate consciousness or always rely on specific steps that humans create for them to follow? So think about that as you're going along throughout this presentation. I'm going to talk about AI technologies enabling cognition and also the moving parts of AI, because I want to show how this is complex, but it's up to us to put it into perspective so that it's more aligned with the business. We want to emulate intelligence with technology, so we're going to talk a little bit about that, and then we're going to look at some of the AI technologies and then the integration of AI technologies. I know this looks a little busy. But remember when we talk, remember when we talked about the levels. Remember I kind of did, I changed the narrative from that little triangle that goes from, you know, data to information to knowledge to wisdom. And I said, you know, we need to insert intelligence into that mix. So we go from data to information to intelligence to knowledge and then to cognition. And we kind of went up the steps to look at where we would wind up, which was that we want to wind up such that we're thinking and we're reasoning with what we have. So when we look at this and we start thinking about all of the technologies and all of the terms that have come out, you see at the data level, I mean, you got structured and unstructured data. So you're going to have a lot of different types of technologies that help you to deal with that as well. And you're looking at, you know, things that help you to structure, to put semantics. You know, again, we're back at verbiage. We need to have business language. We need to understand the data such that we're using it correctly. And then we get to a point where we're in operations, which is the information. And there we want to understand how it's being applied within the organization. And the interesting thing is, at that level, not only do you want to know how it's helping to do the work, but you also want to know if it's sufficient or effective, and also, you know, improving performance, and even if there's some innovation that's occurring. So you have to think at that level, what am I trying to capture as well? And then we get into intelligence, because we take all of that, the operations, the analytics, everything that we're doing, and we kind of mix and mingle those so that we can have insight into what it is we need to know. And if you look over to the left, I'm sorry, let me take this thing down. Over to the right, you see that we're also, then we bring it into knowledge, which is, you know, being able to share that information and being able to use it throughout the organization to improve performance as well. And then we get up to the point where we're constantly monitoring and managing it. And that's where we're using it to think and to reason. But the reason I put all of these together is because these are all moving parts that need to come together under a framework so that it produces a system that works for the specific organization or for the specific community, or however you want to put this intelligence into place. So as we talk about emulating intelligence with technology, this is something that you need mindful of. When you're actually building these systems or putting AI technologies into place, understand how it's being inserted into what you're trying to achieve. A lot of times, and especially in organizations, when we look at even digital transformation, we produce the intelligence, but then we don't find out the value add until much later because we didn't build that in the beginning. Sometimes, like I said, with data, you can have catastrophic effects because we don't really understand the components that are being placed into the algorithms that we're trying to gain insights, or being able to not only gain insights, but to also be able to validate what we have been doing. So as we're thinking, I want to take back to kind of Alan Newell when he had the total cognitive effect of a business. Let's think about what is it that we're bringing into the system? What is it that we need to maintain or store? How do we need to encode this so that we understand it and others can use it? How is it that we need to decode it so that we can bring it out to those who are actually monitoring and making decisions around it? So you take that whole cycle of, okay, we're going to have this input coming in. We have to decode it. We have to store it so that we can use it later, because that's our memory. And so that we don't forget it. And then we have to decode it such that we can then bring it back out to those who need to use it. And all of that has to be done using a computer and also making certain that we're thinking in language that can be understood by others. So as we walk through this, AI technologies are integrated throughout. When we buy these technologies, some of them cover one specific area, some of them cover several specific areas. I tried to come up with a graphic that would kind of show where they all fit in, but as you go up the path, as you see, you're looking at intelligence where after you've looked at your technology or what you're trying to achieve, you have to, or your data, I'm sorry, I'm backing up. After you've looked at your data and you have your data architecture in place such that it can be understood using things like language and profiles and lineage and integration networks, you begin to then think, how do I put this together? So you start thinking about intelligence, and that's when you get into those algorithms that are structured, that are unstructured, that are reinforcements. So you begin to think about, what am I trying to think or say?
Annie, please unmute yourself. I muted all because we had some noise.
Okay, thank you. Can you hear me now?
Yes, thank you.
Okay. So once we get past the data and the processes and the structure of all the things that we're trying to gain intelligence about, we start to lay out the intelligence or identify it. So when you're identifying it, that's when you get into those algorithms where you have structured, reinforcement, unstructured, and you start thinking about, what is it that I'm trying to achieve? And this is where we need the statistics brought into this area, as well as like economics and also econometrics brought in when you're dealing with intangibles. So once we have identified what we're trying to do, we move up a level to representation. And that's when, again, you start to model it. And when you're modeling it, you should understand every component of that model so that, once again, when we talk about things like explainable AI, you can then explain it clearly in a business language. And I'm not going to go through each of these steps, but as you see, you still have to take into consideration, like when we're talking through some of the others, of the assurance of it. How do I determine that this particular model or this algorithm actually is performing the task that I needed to perform? How do I actually have that verified? And then later, how do I continue to train it? So you think through those things, and we get into knowledge. Once we've gotten that intelligence assured, we can then have more integrity in it when we're building knowledge models. So all the way up, we're putting technologies into place that help us to achieve these types of activities until we get up to the top. So again, most of the technologies are going to take care of one particular area, but some of them take care of 2 or 3 particular areas. Okay, so what we're going to do today is we're going to talk about a few of these technologies. And, there are quite a few, starting from, and you've heard of them, they've been around: text mining, data mining, being able to mine your data and mine your text to find things that work, and, being able to then leverage those. Again, from the past, exploiting it, and in the future, exploration, trying to find new ways of doing things. One thing that you see throughout, as we had talked earlier, is there is an input mechanism in some areas that you want to consider. And then there's a process area, and then there's also an output area. So as you are, creating speech, you're also wanting to process speech, and then you want to synthesize it, and you want to then generate it. So in most cases, we're going through each of the individual steps to help us to take it in, to process it, and then to put it out in a version that people can understand. So let's talk about text mining a little bit. You know, we always got this confused with data mining, and it's been around for a while, but you know, one of the things that we realize is that data mining is computer based, and so can text mining be, because text goes with the written. So a lot of times we took into consideration that we could take data and we could mine data, we could put data together, we could turn around, but then when you get to text, text is already structured. So I need to be able to understand the English or the written language so that I can then also go through and look at the position of where words are, the words that are constantly showing together, be able to analyze it to see if I can interpret certain behaviors that are happening within the language. And that, you know, brings you to the natural language processing. And most of this is built off of the basic English language. You know, I always say when you're doing these sort of things, you need to understand what a noun is and how it's represented within a sentence, because then a noun is a person, place, or thing. So you begin to see how this person, place, or thing is being represented within the text that is evident or being mined. In most cases, we look at things like, even when we're doing intelligence, and when I say intelligence, I'm talking like not necessarily espionage, but when we're doing CIA types of intelligence, when we're looking at documents and trying to decode different things that are being said within letters because they're using unfamiliar words, or they're putting different relationships in there that can be decoded by someone else on the other end. Data mining, we have so much data, and this data can tell us information that we may not know. I know one of the things that I used to talk about in the class is that sometimes we think about the obvious, and sometimes we don't think about what is not obvious. So with data mining, we can cross-pollinate this data to see if there are relationships. And one of the case studies that I used to always take kind of pleasure in giving is the baby diapers and beer. You know, when they looked at the study and it was baby diapers and beer, and when the convenience stores saw that they were selling at the same time, and they began to wonder why, and then they stepped into the data analysis field. So when they analyzed it, which is to take it deeper, because, you know, at the top level, we can see that these two products are selling the same. But then when we go beneath, that's when we're getting into the deep learning, especially getting into the analysis. And if we have things already related, then it makes it easier for us to learn. So the convenience store looked at it and said, why are these selling the same time late at night? And what they found out was that generally there was someone who had a newborn baby, and the father would be sent out because the mother had to stay with the baby. And a lot of times, and this is not being stereotyping or putting a label, but men love beer. So when they got to the convenience store, they figured, you know what, if I got to pick up the diapers, I might as well get me a 6-pack. And so they buy the beer. And what does that do? It helps the convenience store to know that these things sell the same time. So if there's someone who comes in the store who's not thinking that manner, if they put the diapers and the beer together, then they increase their sales. So data mining helps us see relationships that we wouldn't naturally see. And it also helps us to verify racial relationships that we have kind of thought were happening. We look at natural language generation, and again, this gets us back to, you know, when we produce text from the computer. We've come a long way with this. I know that a lot of Kurzweil had done a lot of studies on this, you know, with natural language, because he started out with Kurzweil readers to help disabled people, especially those who were blind. But when you look at the English language and you take one of those cheat sheets and you break it down, you begin to see all of the parts. And when you start working with those parts, again, like you look at the name part, the verb part, and you understand that the name part is a noun, which is a person, place, or thing, and you understand that the verb is the action of it, and you start building that into a computer, then you can start to generate this and put together sentences based on these words. But this is not an easy task, because you have so many words, and you need to make certain that you have the meaning of the words as you're putting them into place as well. This area, I think we've done tremendous on, because there's quite a bit with natural language generation and natural language synthesis and natural language processing that I think has come a long way. But I still think that we do have other distance to go, because you need to program this a lot of manual way of doing this type of generation, simply because people have different dialects, people have different languages, people speak differently, people pronounce different words. And even in the dictionary, it tells you like words like turmeric can also be pronounced turmeric. And, depending on how the system picks it up, it might interpret it a little differently. But I think that if one technology that works really well, I think this does. But then you also get, when you're calling in to different, maybe like creditors or to different places, when you're trying to get information and you have to talk to a chatbot of some type, and the language isn't built so that it can know when to exit out, you get wrapped up into a conversation with this thing and it's repeating over and over again. I found that some of them have gotten much better, that when you say, I don't understand, or you ask, can you speak to someone else, it will transfer you. Or now it makes the decision. It goes, I'm not getting through. Let me get you a person. And this is what they're calling human augmented computer assistants. Okay. So the computer is intelligent enough to know, I can't answer this question. Let me now send it over to someone who can. This goes right into what I was just talking about with speech recognition. With speech to text, again, it all depends on how the person talks. And you have so many people who talk differently, and then you have people who have speech impediments who actually, learn how to speak well and then has to pick up on the recognition of it. But again, these types of tools give you dictionaries or personal dictionaries. And that's when you get into that personalization, which also comes from knowledge, understanding, and having a mindset of what people need. So it brings in, it allows you to set up your own dictionary, and you can then pronounce your words the way that you pronounce them, so it will better understand you. So when you're speaking and it's taking it to text, it is more accurate in representation of what you're saying. Speech synthesis. We got from the computer to talk back to you. So you take that text to speech. When you're reading a book, we all have, I know I have my Amazon reader when it takes the text and book. And, even with Word and some of the processing tools, what I do now is if I write a paper, I actually have it read it back to me, which is much better than me reading it myself, because it gives me information about what I've written that I may not have seen when I was reading it on my own. So when it's being read back to me, it actually provides insights into whether or not it sounds the way that I want it to sound when someone else is reading it. So we take this text and we read it back. And I think, again, this has been significant. And this is really, I think, really done well, because we actually use this quite a bit in reading speeches and in reading books and doing presentations. People now, even when they're setting up presentations, they will have the presentation read out loud to individuals. And this helps also with disabilities, because those who cannot, those who cannot see can hear. So we can actually, and that's like a 508 compliance type of federal regulation, that you must make certain that if you're setting up these types of tools, that they actually can be utilized, or that they can support those who are disabled. Computer vision. And this kind of computer vision, I think this is a really neat field. It is really tedious work. It takes a lot of work. They've got to go through so many images to be able to determine how a computer can actually determine that it is the correct image that it's looking at. I've also seen in studies where they show that you change 1 pixel and you can change a lion to a lamb. So, it can be really misconceiving if the person or if someone gets in there and changes something that shouldn't be changed. So computer vision also is very important because we have all of these sensors, and these sensors are looking at images as you're driving, like with the cars. And you need to be careful because there's so much that you need to take into consideration, because even like with the autonomous cars and the sensors that are on it, when the study came out that it did not recognize people of dark complexions in the nighttime, which, you know, should be something that's taken into consideration, but it only shows that you have so many requirements that you need to think about before you put these types of technologies into place. And then we go right back to that step where you need to have assurance that what you're doing is actually going to achieve the results that you're trying to obtain. But, you know, even with this and facial recognition, people have found that, you know, people mature, so things change. People look different. People also have plastic surgery, so things change and people look different. So facial recognition can pose problems. I know in some of the Asian countries, one of the fads that was going on was to have the eyes corrected so that they didn't slant. And a lot of parents was actually buying this for their kids for graduation, and the kids would have this surgery done. So that kind of threw off a lot of the facial recognitions that were already in place. And then you have to think about governance around that. If you're using facial recognition as a tool within your organization, and someone does decide that they're going to change their image or do something with their face, grow a beard, or even put on contact lenses, do they have to have that approved before they make that change? So it's interesting to look at the computer vision and how it sees people and how it's being used. But I do think that this is going to be something that's going to be really prominent in the future. And again, even with the emotion detection, you know, people show their emotions on their face. You know, you got the human emotions. You know, if people are crying, then their eyes usually are squinted and tears are coming down. You know, if your face is tightened up, you can tell that a person is perhaps under stress. It's just different parts that people have studied tremendously in looking at how do people show emotions and how are we able to detect those emotions so that we can, you know, react to or, you know, step in to help. This is our interesting area that I think that this is an area that we really need to perfect: analytics. We have so much data, and I know that there have been successful projects and successful systems, but in most of the surveys and in even companies that I've worked in, I've noticed that there's always a problem back to the data, that the data architecture wasn't set up. And then when they began to, or when they start doing, when they actually start doing their, I'm sorry, I was when they actually start doing their analytics, they build algorithms, and these algorithms are not they're not of integrity. They're not good. So what happens is they get results that are not accurate. And you have different parts of an organization that looks at these analytics differently. So when you have IT writing or data science writing the algorithms, and if the users are not involved in them, by the time they get the results over to the user, then they find out that they have used the incorrect information. So we need to somehow tie these analytics back to either we build analytics databases where we can pull data from that has been verified, and that we have trained systems to put data into there that we know has been validated, or we're going to have to learn how to go back and build the architectures that are built in a language that people can understand so that they know that they're actually receiving the right information. Again, most of the surveys and stuff that I see that come out are descriptive, or they're at the top level, which is kind of the machine learning level. We need to start digging a little deeper and taking these into the deep learning field. To give you even an example, like with the COVID-19, I know that I wrote an article because every time I kept seeing that vulnerable populations were at risk with COVID-19. And then when I did research back to the 1918 pandemic as well, it was actually the same statement. So that's 100 years that we've been making the same statement. So we know that this is happening. It's like we need to start looking at the different types of statistics that take us a little bit further to look at the cause and of what's causing these problems. So I think we need to really look in analytics and start again thinking of the different algorithms that we can put together that are not only descriptive, but they're predictive, which is predicting the future. But you know what? We need to look at diagnostic and prescriptive as well to see how we can start correcting some of the problems, as opposed to for 100 years reporting the same thing, that vulnerable populations are more at risk. We need to start saying, why are vulnerable populations more at risk, as opposed to giving the information that we've already known. We then have, once you get into, you got image and vision types of analytics. So we are capturing all of these dynamics of these visions. This is a lot of data. We're not talking about, remember, an image is not like a data where it's a bit and a byte. It is actually has to bring everything together, and it goes through some types of number crunching so that you can have a key field or identifier that recognizes that image. So those are things that I think are a lot more verified than the data that we're working with. But I think image and vision analytics are, they actually have tools. They have software packages that help you with image and graphics. And, you know, these have been around for a while as well. So those are the type of things we need to look at when we're actually doing a lot of number crunching around image and vision. And then text analytics. Again, text analytics have come a long way. I think that if the written word is a little bit, I think, easier to analyze than data, and simply because the written word, we know, we have dictionaries and we kind of know the understanding of words, and we're right back to semantics. But with data, data is raw and unstructured until you put it into a structured format, and that's where we need to actually have that architecture take a prominent place in how we're establishing our base foundation. Sentiment analysis, again, that's right back to being able to look and see what people's emotions are and then store it. But again, we need to think different people react differently. And when you have different behaviors and you have a different effect, some people, if something scares them, they will cry and freeze. Some people, when something scares them, they will react and become violent. So those are things that we need to build into that and understand the differences amongst people. And this is where we get everything from. This is where, as I even read the studies now, and as we're going more and more into the neural networks, and of course, this is based around the neuron system of the human. And I'm seeing more and more schools now actually putting programs together so that you can begin to understand neurology and how it works, because that's going to be kind of critical with these neural networks. We're not doing the colloidal effects of man, but we're actually doing the relationships of data. So we're trying to actually mix and merge all of these data elements so that we can then be able to pull information from these neural networks that give us insights, and also give us not only insights, but actually predictions about how we should move forward in the future. Now, there are several types of neural networks that we talked about. Most of them are basically, again, they're huge. They need to be managed. Of course, we have the internet, which is one of the biggest neural networks out there, but we need to, within an organization, you would need to protect this. So you need to understand it. You need to be able to understand the relationships. You'll be able to understand, what relationships are structured, which ones are unstructured, which ones need to be reinforced. You need to actually map this out and have a clear view of how the relationships are established, or build a artificial intelligence tool that can go through and read these neural networks and give you insights into what is constructed. I talked a little bit about machine learning and deep learning. We can learn at the topical level. And, this is the same sort of thing that we've been going through and we see now in the news too, even like with diversity. You have surface level diversity when you look at a person and you can see, what they're composed of, but you can't see what their intellect is, you can't see what their skills are, you can't see what their experience are, you can't see some of the other deep lying things that you need to know, or the causes that make them the way that they are. So we need the deep learning, which is when we take it to the further levels and almost down to the primitive level of what is the beginning foundation of building the structure and how did that help to create or to give us the algorithms that we now are looking into. So machine learning is that top level. Deep learning is when you start taking it down. Remember, and using factorials, as you go down, you're going to get so many more combinations depending on the levels that you go. Now, you may not want to go down to the deepest level, but which I call the primitive level. But if you go down at least 3 or 4 levels, you're going to have a significant amount of combinations to begin to mine and look at and determine what it's trying to tell you. And then we have this automatic human action in business processes, robotic process automation. We've been doing this for quite some time again. And one of the things that we are looking at with robotic process automation is you're looking at routine tasks, things that can be done through automation. And I think in some organizations that this happens, but unfortunately, a lot of organizations, robotic process automation is built off of processes. And in a lot of organizations that I've seen, processes have sometimes been put on the back doorstep. In other words, we don't update them. What we do is we keep building and we keep working and we keep working. So what happens is an organization actually begins to depend on the practices of its individuals rather than on their processes, which should be how the university is running. Not university, which should be how the organization is running. And just to give you somewhat of an example of that, if I am with process, if I have no processes and I am allowing just the practices of my workforce to sustain the organization, then remember, and we talk about ethics, you have so many variations of what people think or value at certain points that you may not be working then with the value system of the organization, but you will be working off of individual value systems, which might not be aligned with how the organization feels that it should be executed. So what happens is, in this case, you need to really think through the processes and you need to align them with your strategic direction and align them with the value system of the organization to ensure that you are covering or making certain that all individuals within that organization, as well as customers outside of that organization, are being satisfied and treated with morals and trust and dignity. So automation of our business processes is going to take, I think, a little while. Some of them are automated, but unfortunately, I think that in most cases, we still follow on the practices of our individuals or workforce, which makes it a little bit more difficult. But some organizations are very, I don't want to say totally bureaucratic, but like when you get into like a federal space or a military space, they are heavily ladled with like processes. And with those processes, it would be, you could then see into it and determine, again, what works and what doesn't work and what you need to take out. And then you can pretty much identify a streamlined process and identify the points of automation within a process. Decision support systems. Again, this is an area that has been around for quite some time. Expert systems were out and about. We were trying to determine or help with experts. We were trying to capture the knowledge of experts, put it into a system, and then be able to leverage, I want to say laymen, to actually be able to perform at a higher level. So what happened to expert systems? but pretty much technology could not accommodate them. Expert systems were if-then systems, which are heuristic based. And what happens is you get combinatorial explosion. Now, notice I said combinatorial explosion. Remember, if we don't do networks correctly, then we could wind up with the same problem of combinatorial explosion. What happens is you have too many combinations and they can't be managed. And then also with too many combinations, the systems could not handle them. Now, I don't think we'll have a problem with systems, but I think we might have a problem with managing them. And then we had case-based reasoning or case-based evidence, which is explainable AI. And when you do case-based, you're actually looking within a particular scope and identifying key fields or key elements that you are putting together in order to be able to seek results. And using those case-based reasoning is actually one of the great ways or perfect ways of using decision systems, because you then have it scoped and bound and you can actually have more visibility into what you're using and how it is respecting the result, which is good for explainable AI. These little fellows, I like them now. Virtual agents and chatbots and all of that. There was a time when they were coming up that I truly didn't like them because I couldn't get an answer from them. I found that they've gotten so much better, and in some cases it's even the Turing effect. I find that I can be talking to a computer and I realize that I didn't realize I was actually talking to a computer. So I think we've come a long way with this. You look at things like even Alexa and Siri and just all of those that are out. They are to me more helpful now than they were in the past. I think that a lot of organizations are going to be using them, especially when we start to look at agents as being agents. It's the same concept of, if I want to buy a car, then I go to a car salesman and that's an agent. If I want to buy a house, then I go to a real estate agent. So here we are, remember, combining them, because like with the real estate agent, I'm taking their expertise and I'm putting it into a virtual agent so that when someone calls in, they can have a bot talk to them and talk them through the very same things that an agent would have talked them through. But not only that, if the system is looking at the dialogue and what's going on, it can actually place them with the agent that would be more successful for that particular client. So, we just need to make certain that our agents are presenting the information that we need to present and pulling that information in so that it can be analyzed, so that, again, we gain the intelligence and then we pass it on as knowledge so that we can then improve the performance and streamline the activities that we're doing. So chatbots, I think, are a way of the future. I really think even with network systems, once network systems are developed properly and you have these AI interpreters that are out there with our networks, that we'll really be able to tie them all together and be able to talk and have dialogue and conversations with computers. And this brings us to the AI optimized hardware, which is, we have AI running quite a few things. We have AI running in our cars, you've got GPS systems. This hardware is firmware that's placed into specific boards or motherboards or any types of performance boards that have intelligence built into it. And not only does it have the intelligence, it's actually gathering the metrics so that it can see where where errors occurred, or it can improve what it's giving to the customers. So these AI optimized hardwares, again, when you think about it, like with products, we also need to look and see what is already existing and where we can accommodate it within our organizations. And it, like with phones, we got mobile, we have the PCs, we have apps, we have all of these types of hardware that we plug in this optimized cards and different things that actually help us to work and move about and be able to conduct business in a better and a faster, here we're back to this faster, better, and cheaper way. And biometrics. This natural interactions between humans and machines, we already talked about like the language and different things, but even when we're looking at, and even with biometrics, we, especially in health, we're looking at different machines being able to give natural interactions, being able to bring back, even like when we look at you, you're talking about, you see the fingerprint there, being able to find through a fingerprint and detect all of this matching using the different data that we've captured using biometrics is going to become important. Now, one thing that you have to think about with this as well is just like with the vision and or the face recognition, with biometrics, people can burn a finger and that might change a specific fingerprint. People can, you know, blood can change. Different things with biometrics can change in a person, and those must be taken into consideration when you're actually doing these interactions. Now, is that significant? It may not be. You know, even when we're looking at right now with, they just released Johnson and Johnson back. What was causing those blood clots? But it was in a very small percentage of people. So maybe there's a common mix there that they can look at and see why that particular substance caused those particular people to get blood clots. This is something that is critical. The digital twin and AI monitoring, we have to actually recreate our reality. So when we're building these things, and I think I used the example like the typewriter, when we built the word processor, we took the typewriter and we copied everything over so that we were aware that it started at the foundation. Now, did we improve it? Yes, because we started to integrate other projects, other types of technology, and then we got to convergence. I mean, when we look at it now, that typewriter is also, you can do graphics with it, you can do tables, you can do all sorts of things now that started out as a typewriter. But the key is, in each case, that digital twin started out as something that was real. Even when we talk about agents, if we're developing a virtual agent, then where does that agent fit in the real world? Like I was saying with a real estate agent. Okay, a real estate agent is supposed to be an expert on real estate. So if I'm developing a virtual agent for a real estate agent, then I need to understand everything that is occurring with that real estate agent such that I can have its digital twin within the computer realm. Same thing I said with the organization. When you're trying to build or put cognition into enterprise, you actually want to understand how that's supposed to work or how the enterprise works so that you can then build a digital twin of that enterprise so that you're aware of everything. This also helps with semantics, because when you're building a digital twin, you know, you want to call it what it is at the time. Now, if the language changes later, you can change the language later. But you know, at the start, if it is an apple, then call it an apple, and people will understand what it is. And you can also have a reference to go back to so that people being trained will understand this is how you did it in real life, and this is how the computer is doing it. And this is where you must augment the computer, because these are the pieces that could not be automated. And then we got swarm intelligence. And you know, a lot of this all works together. Swarm intelligence is, it's almost like everything's ubiquitous. You have all of these data points or all of this input from everywhere. When you have an autonomous car driving, there are other cars on the street, there are other people on the street, there are signs, there are routes, there are all of these areas or all of these components that need to be taken into consideration when you're building the intelligence. And so you need to, even as we're building like with communities and enterprise, and an enterprise fits into a community, and a community fits into a state or a township, All of those things come into play when we're building out all of this intelligence. And that's called swarm intelligence because it is ubiquitous. It's kind of all over the place. We have apps now everywhere. We can track down where kids are. We can track and monitor where cars are going. We have trackers on people, even, and on dogs, animals, they have trackers inside of them. So all of this is the complexity that we need to be aware of, and it needs to be part of the dynamics while we're setting up this intelligence that's going to help us to operate better. And then we get to semantic AI, which is basically an AI strategy. And the reason it's semantic is, again, because this is wordplay. We have to be able to talk the same language. We have to be able to talk in whatever discipline we are placing AI. We need to understand what the terms are, what they mean, and how they're to be duplicated within a digital realm, and then what the outcome is going to be or what the results are that we're looking for. So in the end, technology enables. Know the technologies you're integrating to build an AI system. This is where, again, it comes into personalization, and also the fact that you want to personalize it to not only the individual, but also to the organization. So you want to build these AI systems with strategies that include all of the components that I've talked about, which is make certain that your data, which is, that's the nutrition of that system. Make certain the data is correct. I know a lot of organizations sometimes don't put very much investments into data, but sometimes we got to take a step back to make certain that we have the foundations in place that we need to be successful later on. Again, with information, a lot of it's process-based. We need to understand our processes because our processes is an area that we may want to automate. And if we're going to automate it, then again, we have to understand it so that we can make it equivalent in the digital realm, and also then identify where the gaps are and where we have to have augmentation. Intelligence, knowledge, and cognition, those are what we're seeking. We want to have knowledge into what we need to change and how we need to change it. And then, we want to reason and think about it so that we can synthesize it and perhaps expand it. Bottom line, every enterprise needs to feed AI the required data with high levels of quality and consistency. So here are some further learnings. And we come back to our discussion so we can talk. Our discussion is, will computers emulate consciousness or always rely on specific steps that humans create for them to follow? Because we're building the systems. So Moria, we want to open it up for questions?
Yes. We want everyone to think for a minute and say what you think will happen and maybe why you think. And you don't have to come with exclamation marks. You can come with question marks or think about aspects, because we are here together in a brainstorming session.
Mm-hmm.
Who wants to start?
So I just posted in the chat the first definition of consciousness. And by that definition, I think it is already here.
What? The consciousness?
Consciousness.
So,
digital consciousness.
So,
So I don't think it'll emulate human consciousness, but it will develop its own digital consciousness. Absolutely.
I think I'd agree. I think you're not going to emulate human consciousness because the inputs will be entirely different unless you constrain, or this is based on what you've been saying, unless you have the same inputs and outputs, it won't emulate a human. And how can you emulate 10 years of growing up with when you've got completely different senses and access to the world's data and unlimited brain processing power? That will be quite interesting. I want to say I'll be back at the end of that sentence as well, but that's probably not the best thing to do.
I have a different take on this, the Santosh here. I think consciousness, I think it's probably this question is too fast and too early. Maybe this question should be asked after 20, 30 years from now. Maybe, you know, what we thought was, 400 MB was during 90s. And now terabytes, I mean, it makes more sense. Maybe, you know, we have to wait for that for 30 years, maybe, you know. I think consciousness itself in itself is it's a challenging subject for humans, and I'm not sure how the technology or the digital will be conscious of itself. I think that's an amazing concept, but well, I think it's a few decades early question.
What about
understand.
awareness? Because consciousness is awareness, which is what we're looking toward.
I have some thoughts. I think.
Sharon, if you can speak a bit, turn on the
Yes.
volume.
Mhm.
Hang on. Yes, let me see. Can you hear me now? Could you
Better.
hear me?
A bit
no,
better.
I think my thoughts on it is that I think the computers are getting so much better. And I think I could really relate it to when Dr. Green was talking about chatbots, right? When it first came up, you know, it was quite frustrating because even, at the time it wasn't so good, but, you know, I've been actually, I've been quite impressed with the levels, the level of sophistication that you have nowadays. But I don't think that computers will totally, think like, I think we can rely more on the data that it processes to help us make decisions, but I don't think it will completely replace it. Yeah, at the end of the day, because I think it would be a bit dangerous to go down that line as well, because I mean, I think the computer, whatever results come up from the computer, I mean, will depend on there is biasness there, there's biasness from what is that information that goes in, and I think we need to be just very careful of that, the biasness, because thought leadership and all that. I mean, in the legal industry, for example, I think we can actually, there are analytics that can actually predict results that happen in the future, right? Based on past decisions that have been made. But going forward, right? I mean, the thing about cases and law is that it also develops. So my answer to that, I don't think it will emulate consciousness totally.
Mhm.
Sharon, if I understand you, you're saying that we have here two separate issues that we should think about each one separately maybe. One, can the machines go further and turn into be general machines and not only task specific? And B, do we want it even if it can do it? And you are now giving some concerns that have to do with the legal industry, for example, but ethics, of course, come with other industries as well. And maybe we have other reasons. You're saying that the future is maybe not only linear to the past. So maybe we will want to think for all kinds of reasons. Maybe we will want to stop it even if it can be performed. Rizwan?
Yes, please. Thank you. Well, I just want to put it very simply, because we are the creator of the AI. So the creator and the created thing cannot be greater than the creator. That's simple as it is. That's number one point. The second point is that the consciousness level itself, we general public, or even say for the monks or the yogis or those special group of people having the special wisdom, they are actually a group of people actually talking about the conscious level, but the general public, they're yet to grasp the whole idea of the conscious level of our own. So if it is the level of the understanding about the consciousness within the human aspect, and how can a created thing of the human mind can actually overcome the human itself, or the creator itself. So that's the basic point. The second point that you have raised is whether the ethical issues also. I think ethical issues is driven by more of the political nature of the system, because of the fact that the business behind the political doctrine or the political philosophy of that particular business entity, or the political economy itself actually will determine that how they actually will use this thing. But so my understanding at this point of time, the human intelligence actually will prevail, not the artificial intelligence. That's it from my side. Thank you.
Thank you. Arief.
Thank you, Moira. Well, if you go back to one of the classes, we talk about risk, and then what are the things that's going to happen if AI sort of takes control, and what happens to the human being. I think this is some of the fundamental things that we are talking about here. And when you question just now whether if AI is just going to be a very generic thing that can cover everything, or is it something that is going to be task specific? I believe as we progress, the level of tasks, the complexity of tasks that the AI can do will actually increase. Because why? When I look at automation, also when I work with data before, the more we focus into the deep diving into the data part, we found that we can do. There's a lot of human things that we need to do, a lot of human processes to understand the data more. But then we take away the processing part and we get computers to do it more, so that we can focus on the qualitative part better. So from my perspective is that it depends on the complexity or the progress, how we create the models that we wanted to put in. Yes, we can, but however, I agree with everyone. I think it's perfect. You cannot get full consciousness, but when we talk about awareness, I mean, it's something available now. And we look at, CCTVs, monitoring system, when people walk in, the lights will turn on and so on. So in terms of those kind of awareness, it's here. It's just that, again, it's how we program it. It all depends on us. That's my take.
Wow. Okay. So we are superheroes because we can program it. Kaushik?
Yeah, good evening. This is a very good question in the sense that consciousness and logic, I think there are two aspects of it. Just now we are, even in some image processing and all, we still really are not able to say what is right and what is wrong. I mean, we are looking at yes, no, this thing, and we are not still able to, come to a complete conclusion that artificial intelligence is able to judge what is correct or what is incorrect. Why consciousness? It also gives, it is an added dimension in which it says what is morally, or somebody said ethically right or wrong. I think we need it. It is, it is very often dependent on circumstances, dependent on context, and a human mind is able to interpret that in a much better way. I am not sure as of now the technology exists, or even we can aim for, consciousness in artificial intelligence. I think we are still a way ahead of it. First of all, the logic part is still to be done across multiple systems, whether it is voice, whether it is image processing, whether it is something else. But I think the human consciousness will take some time for artificial intelligence to mimic. Thank you.
Thank you. John?
Yes, thank you. I sort of hesitated to answer because my answer is going to sound a little self-serving, but I can't get away from it in my research and the need to understand story structure, and not just storytelling, but story structure is a story structure. We know from neuroscience is what we are wired from. Humans are wired for stories, and understanding that story structure, I think, is going to take us to that next level. Right now, I think we have something in between what I call artificial guessing, or something using game theory as the underlying process. But when we move to and start to understand really story structure as the underlying process, then we have AI that can also emulate sense making and lessons learned. That includes hypothesis generation as well as codified routines. All of that fits within story structure. And I think that when we move to and really start to understand that story as the underlying AI process and not game theory, I think we will reach the level you're talking about.
Okay, so we really do not agree. We have different ideas and thoughts here. Corey, do you want to speak? Because we're seeing you're speaking through the, other channels. Please, Corey.
So my thought is, for consciousness to really take hold, and the AI has got to recognize what is good information coming in and what is bad information coming in. So with that, it's got to determine, if bad information is coming in, does it extrapolate from that? Does it not? So I don't think, one, we're in a point of where we're programming to that level yet. And then two, what type of, environmental sensors, will this AI have to be able to, extrapolate what is good, what is bad, and what can it process? So I think it's a couple of fold here. How will it read the environment? I know we talked about, imaging sensors, bio, and everything else, but in terms of fully conscious awareness of for an AI, I'm with a lot of folks here, is that we're quite a few years away before we actually get to that point.
Okay, so it's not a yes or a no, but maybe it's a route, and it's a long way, journey that maybe we will, but it's a long journey yet. Yes, dear guys, we saw also, yes, also Hukai. Please, Jen, we are with you, and then Hukai, yes, please.
I was just going to say one thing that it seems to be maybe a line in this is whether or not we're expecting the machines to actually be conscious or just emulate consciousness. Because I think we are closer to emulating consciousness than saying, oh no, the computer is actually this perfect human brain that can reason. Because you look at studies where, essentially the Turing effect, if you are having a conversation with a computer, I was reading recently about where a person was debating a computer, and the amount of data that can be kind of in that can be processed by the computer that isn't necessarily a pre-programmed set of if-then steps, can give the appearance that computer is having a conscious conversation, conscious discussion with another person. So I do think that's a little bit closer, as long as you don't start to take it as to, oh, well, is the computer actually being conscious as a human brain? So.
Okay, so we are emulating it, but we're not really trying to do it.
Mm-hmm.
Thank you. Hukaya wanted to speak. Do you want to speak, Hukaya?
It's actually Ian Hook. That's just my Novartis email address. I don't know why it is. Unfortunately, I can't go on the camera at the moment because I'm also struggling with 2 little girls who are at home because of lockdown. My point is, what is the point of emulating human consciousness with AI? What are you actually trying to achieve? And especially in the context of, we're here to do AI for knowledge management. What are you trying to do there with an AI in relation to a business need that solves a problem for you? And why is it better to have an AI do that than it is to have a person to do that? Isn't it better to build a system which fills in the gaps in what humans aren't capable of doing? So identify the things that people aren't capable of doing, and then have an AI fill in those gaps, which makes humans then more powerful to do the jobs that they're good at. And this concept of human plus AI systems, rather than try and do stuff badly, which we're already good at ourselves, right?
Thanks, that was creative. Annie, I'm passing the leadership again back to you, the facilitation. Do you want to add and sum up these thoughts and your thoughts? Annie, unmute yourself.
Sometimes the mouse gets out of control, so I couldn't unmute. Yeah, one of the things, and great conversation, and I totally agree. And that was I'm trying to think who made the last statement. A very good statement. I totally agree with that. But what we want to think about too is, again, always, like I said, leverage sometimes what's in the past. Now, when expert systems first came about, one of the things was they were in the medical field. And within the medical field, they could help quite a bit in helping to a doctor with their diagnosis, so to speak. But unfortunately, the problem came about that doctors felt as though they were actually giving them directions as opposed to giving them recommendations and alternatives. And this is the reason why we need to think about this, because to me, it does not replace the human. And we have moved to a point where I think we reason, we think, we know, but we also need to be conscious of what decisions we need to make and how the computer is actually supporting us in making those decisions. So what happened is expert systems were kind of taken off of the shelf and couldn't be used in the medical field because it governed human life. And I know some people said, well, why? That might be a small percentage. But then when you think, would you want to be on the table when a computer diagnoses you and they make a bad diagnosis and the doctor actually follows through with it? And then you come back, who's at fault? Is the doctor at fault, or is the computer at fault? So there are a lot of things that we need to think about when we're building these computers. And you're right, we need to think about the consciousness of them, but we also need to think about the routine activities that we can have done that will help us to do things faster and better. But we also need to know where humans are augmented and where we add value. I don't think they will replace us, because someone always has to program the computer. But I do think that we need to know the boundaries and the limitations and know how the technology is inserted into the way we work and into the results we're trying to achieve.
Thank you.
Okay.
Great. Okay, so where does it leave us? It leaves us with smarter and smarter machines. Yet we are smarter than them. We still program them. They program the chess, but they're winning us big time in chess and Go and other things that we programmed. So we have to understand the limitations, and we have to understand that even that we program them, sometimes they will win us or overcome much further than we even dreamed about. So that takes us to the next week, and next week, Vincent will really be speaking about what would be today, about the big question, can AI be creative? And we can already tell you, AI can be creative. So please wait and see, and we will meet next week. Thank you all.
Thank you.
Thank you very much.
Thank you very much.
See you next week.
Thank you.
Thank you. See you next week.
See you next week. Thank you so much, Anne.
Bye.
Thank you.
Thank you.
Okay, I believe we are now closing. Annie, I think they're getting into it.
Yes. Yes, I can't wait to.
Step by step.
Yeah,
and also
yeah.
Today you were speaking more slowly. You were not afraid not to catch up, and I think that was great.
Thank you.
People are understanding more and hearing the things more than one time, because we're not saying only new things, but also deepening into things that already were spoken, talked about, and so people understand better, I believe. And I think that we were all more relaxed and all more, and it was great.
Yeah, yeah. I think it's going great. I can't wait to hear Vincent next week. You know, and then I'm really excited about, I think, us bringing in the speakers. I really do. I think those are going to be really good.
Okay, so Vincent that's 3 weeks from now, we will be speaking because we need to, maybe we will have not a brochure, a poster that we will put on the internet, on the LinkedIn before, regarding this lady from World Bank.
Okay.
So
you want
we asked for information, you remember, but we didn't get it yet.
Yes, I mean, over the past 2 weeks, I tried to reach her and she was not answering, and she finally answered to me yesterday. So
good.
She was super busy, but she's still on. And so we are trying to schedule a meeting time this week or next week before our interview in 2 weeks, but in 3 weeks. But we are, yeah.
She's part of
everything
the
is on.
course. If I remember correctly, we added her to the course. She's with us, right?
No, I don't think she has
Oh.
been joining us up to now because she was still wondering.
Busy.
I mean, yeah, she still had some question or whatever. But yeah, you invited her to join, but I think she didn't. So
She didn't have the time yet. Okay.
no, but so I mean, when I will talk to her, I will again tell her that she's welcome to join anytime. And but yeah, let's see if she will do it or not. But for sure, she will be here on the 18th.
On the week she's speaking.
Yes. Yeah, the week she's speaking.
Okay, so if you can just see that within a week or two, you get some, something that could be a teaser for the meeting,
Yes, a
something that we
short,
can put on LinkedIn, her profile, her picture, maybe a few sentences teasing.
yeah.
So people will come in.
Yeah.
Yeah, I will collect that. Yeah, for sure. No worries.
Okay, thank you all.
Okay, great.
Thank you.
Great job,
Have a
Annie,
great day.
and,
Thank you, Vince.
Okay. And I will,
That's the time to say good morning, Annie. Good night, Vincent. Good afternoon. Good day, Maria.
yes.
Absolutely. Well, enjoy where you're at.
Yes.